So now, after doing the schematic drawings, some of the team will go to the protections, and some of the persons are doing the cable schedules. So what is the cable schedule? So my schema, when the schematic drawings are finalized, now it's a time to prepare the cable schedule team. So what is meant by cable schedule? So cable schedule will tells us what the size of the square or number of core, what is the number of core or the size of the cable I required for a particular application. So what is the length that I have to lay from X to Y? So by doing all this, I can generate the total cable quantity required for the substation. What are the different types of cables and their quantity and their lux and their glands? I can conclude by doing all this cable schedule. So to prepare the cable schedule, what are the drawings that should be finalized in prayer? One is my cable routing layout that should be finalized to calculate the cable's length. Second one is the schematic drawing. The third one is the all electrical equipment switchgear. I mean all electrical switchgear drawings. All the electrical switchgear drawings, manufacturer drawings. So now let's see the cable schedule. So this is the cable. See again, the cable schedules will be prepared for every one control relay panel. So we are generating a cable schedule for each control and relay panel. So this is a cable schedule for our 33 kV feeder panel, what we discussed now. So let's see the cable. This is our way of our design team. So you can, it's if the client is proposing some format, you can do that. So this is our format we regularly use for our applications. So you can see here the cable ID tells us what is the cable, and for source and the destination. In the source you can see the equipment, from which equipment it's going to the which equipment, and in the middle you can see the terminal numbers and the ferrule numbers, and what is the type of the cable, and what is the functionality of this cable, and what is the length of the cable. And this column tells us the what is the 10% margin on this length to calculate the total estimated length and considering as a 6 meters. And gland is forget about this. This is just my representation. I am telling that 6 core 4 square mm. I am taking it as a 9. How it comes, I will show you that. So this cable ID directly will tells us what the cable it is. C represents a CT cable. Before I already told you. So just go to our this feeder panel drawing. So from where this is the first page, right? So we have to start doing this cable schedule from the starting page. So let's see. So again, I'm saying if there are the 2 boxes, it represents there is a cable between. Okay. So in this page, we can see 2 boxes. So I have to lay a cable from SFDB to CRP. What is the cable? AC cable. AC cable, what is the representation for the AC cable? H. So H1, H2. And from where to where it is connecting? It is connecting. I have to lay a cable, a 2-core cable is sufficient, that to be laid from 8N terminals of SFDB to XAC 1 and 2 in the CRP panel. AC 1 and 2 in the CRP panel. So this is the cable I am laying now. This is the cable I am laying now. So this is the 2-core cable. So I am doing the 2-core cable. Where I laid this, come down. Yeah, you can see here. This is the one from SFDB to CRP. This is the same cable I am laying. Okay. From where it is laying? It is laying from SFDB to CRP. And these terminals are represented here. And what is the cable? Only two. So 2 core 2.5 square mm. All the control cables are 2.5 square mm cable. And this is the AC cable. What is the length? It's a length is 62 meters, which we got from the cable routing layout. You have to route that cable through that trench, and I found that is a 62. Taking 10% on this, 6.2. So adding this to 69 meters. So in this, the cable is finished. So we are moving to the next one. In this, I can see 3 boxes. So there should be a cable that should run from DC subdistribution to the CRP panel and DC subdistribution to CRP panel. So these are the DC cables. So these are J, represented with J. J 101, 102, 201, 202. Come here, go to the down, go to the J, J101, D1, J01, D1, J02. These are connecting from subdistribution board 1 to CRP, 2 to CRP, and those are J101, 102, 201, 202. And again, these are also 2 core 2.5 square mm and DC supply. So this is how I represent it. And this is fine. Now come to this. In this page, you can see only one box. So no need to mention no need of cable here. So this whole thing will be done by the OEM itself. So going to the next page, this is also fine. Come to here, yeah, I can see again here 2 boxes. So a supply is coming from PT distribution board to CRP panel. PT distribution board to CRP panel. So 2 cables are there. 1, 2, 3, 4 core. I required 4 core. And one is for metering, one is for protection. So whatever it may be, the representation could be E only. So E 111, 131, 151, 171 are for the metering. E 311, 331 are for the protection. So let's go to again. Go D1 E01. Yeah, PT junction box 2, CRP 311. These are the protection, PT protections. 4 core 2.5. And PT distribution board 2, again, E311, all this, or 4 core 2.5 PT metering connections. And here, you can see in the CT here, come to the CT, this is one box, this is one box, and CT. So I have to lay a cable from CT to CT junction box and CT junction box to CRP panel, right? So let's see the CT to CT junction box. So 2S1 to TB2, 2S2 to TB2, all this I have to lay the cable, right? So that is this. R phase, Y phase, P phase to the junction box. And the junction box to CRP panel. One is for protection, one is for metering. That is, one is for protection. So protection, what I'm doing? I am connecting CT junction box TB2 3, 2, 3, 6, 9, and 10 to CT 1, 3, 5, 7 in the CRP panel. Let's see. Yeah, metering. So 1, 3, 5, 7 connecting to 3, 6, 9, 10. Right? So this is for metering. And these are the ferrules. And for the protection, go to the next page. So here I'm connecting 1 to 11, 4 to 13, 7 to 15, 6 to 18, 17. Same. 1 to 11, 4 to 13, same. This is for protection. And in the CTs, it is recommended to have 4 square mm cable. Remaining all are 2.5. Only for the PTs, 4 square mm is required. Okay, this fine. So this is also no boxes are there. Only one box. In this, I am having a box CRP panel and also breaker. So I have to lay a cable from X52 1, 2, 3, 4, 5, 6, 7, 8, 9 to breaker 354, 356, 352, 419, 411, all this, right? So these are all should be shorted. These are all shorted. So one is connected to 354, two is connected to 53, 55, 51, 418, 410, like that. So what is this? This is for indication. So I have to lay a cable from the breaker to the CRP, which I require nearly 10 core cable, right? Nearly 10 core cable. Let's see that. That is always represented in K. Come to the K. Yeah, you can see here the breaker, T152, T152. Yeah, you can see here X52, this 1, 2, 3, 4, 5, 6, 7, 8, 9, connecting to 354, 353. This. So this is 9 core. So you can select 9 core cable team. But we are having this cable in other for other applications. So why to purchase again a 9 core cable separately? So here we considered 14 core for suppose for spare having some spare. Otherwise, you can consider 10 core also. So for what is for this is for CB indication, breaker indication. And similarly, isolator also we are providing. So like that, we are preparing all this. What are the things are there? We have to represent everything in this. And also in the cable schedule, we also represent, is there any loops to be done or not? Loops also we have to mention. Loop in the sense, let's see. Come to the first from the first one. Here I am talking about any loops. No loops. But here, if you see, I am talking that okay, this is 3 connecting to 3, 6, 8, 9. Yes. Now you can see that the CT, TB2, 1, 4, 7, and 10 should be shorted, right? 1, 4, 7, 10 should be shorted. TB2, 1, 4, 7, 10 should be shorted. There. Connect to the Got my point, Chief? Similarly, here in the CT protection case, 9, 6, 3, 10 should be shorted. TB1. This TB1, 3, 6, 9, 10 are shorted. This also we have to provide. Because who will done the shorting? So again, we have to do that one. And come to the next page. Here, no. Yes, again here you can see. 354, 56, 52, 41, 419, 411, 415, 407, 405, all to be shorted. This is about the breaker. So this loop. And isolator. TB3, 2, 12, 6, 3, 14 should be shorted. Okay. So that loops also we have to mention. So from this, this is our design. So from this, you will get what are the cables and what is the length. So before I said, right, this is the formula I made. Suppose 4 core 2.5 square mm is the 3. So this 3 is appearing here. So now I can sum up how many 3s are there here. So I can get number of glands. So suppose 2 core 2.5 square mm. I got 10 cable, 5 cables. So 5 into 2. On the both sides, we require the cable, right? So gland, right? So that is the gland on the both sides. And if you see 10 core 2.5 square cable, it is appeared 11 times. So 11 into 2, 22 glands are required. This side and that side. And if you see the lux, 2.4 10 core means 2.5 into 10, right? Nearly 2.5, sorry. 2.5 10 core 2.5 square mm. I am having 12 glands means I am having nearly 10 core 11, 10 core 2.5 square mm cable. Each cable, I required 20 lux of 2.5 square mm. So 20 into 11, 220 lux I required for 10 core 2.5. So hence I am calculating that way, and it was seen that 352 or the total lux required. And the 4 square mm is 52. Because the 4 square mm, how many square mm? This is the one. This is the one. So 4 plus 4 cables means 2, right? 4 into 4, 16. 6 into 6, 36. 16 plus 36. How much? 52. So 52 lux required. So this is the lux. So they will give the lux, the gland, and the length. Total cable length will get for each panel. So in our project, we are having suppose 20 panels. We have to do this exercise for 20 panels. So we have to submit that to the field. So the field engineer will cut the cable according to this. And again, if your design is accurate, so he will cut according to this. Otherwise, in the field, they will again lay the cable and they will cut according to the site conditions. Because most of the cases, what you designed, that is not exactly replica of the site. According to the site conditions, they will change the design. So it's better to again cut the cables with respect to the site design, site conditions or site thing. So this is about the cable scheduling. So any doubts in this? So what is the main thing we need to focus here is, one is the representation, and the other one is the cable ID selections. Again, C for what we discussed, C for protection, T for metering, that thing we need to know, and we need to represent this. So any doubts, team? This is about the cable schedule. So we have to start the control, and we completed the controlling part of it. So we have to start the protection. So protection means CT is first overcurrent protection, directional, non-directional, followed by directional differential relay, and followed by distance protection. And then we will move to the ETAPS class. So these things are pending with us. So let's see, maybe if tomorrow possible, let's have again a class. Otherwise, on the day after tomorrow.